All right, here's a second problem for our exam review. And so this one is along the lines of, it's from chapter 6. And again, it's going to be working with exponential values. This one, they're going to give us a model, and we have to be able to interpret the model. So it says that a computer purchased for $1,250 loses 13% of its value every year. The computer's value can be modeled by the function v of t equals a times b of t, where v is the dollar value and t the number of years since purchase. In the exponential model, a equals what and b equals what, and then in how many years will the computer be worth half its original value? For the purposes of our exam, what we're going to be looking at is you might actually be asked to develop one of these exponential models. And in general, they all look like this, right? A times b of t, where a is like your original value, original cost, and b is is how fast it is growing. So sometimes it's e when it's continuously compounding. Sometimes it might be a t2 or 1.01 or whatever. And so we have to actually understand how it is that we're going to find both a and b, right? And then how do we use them? So what I'm going to look at here, and I'm going to notice that the computer is purchased for $1,250, and it loses that 13% of its value every year. So what that tells me is that I kind of imagine this and I say, okay, well, it starts out at 1,250. So automatically A is going to be 1,250. That's actually how they're generated. That's my initial value. And because this one is, something where either we're increasing in terms of its value or decreasing in terms of its value by a set percentage every single year, my B is going to equal, in this case, we'll start at 100%, and then it's going to lose value, so it's going to subtract 0.13, okay? So this is the percentage lost as a decimal. Okay, so that equals 0.87. With that, actually, we now have the entire model. Okay, so the amount, right, or what is this? The value, we'll call it v of t. V of t is going to then equal 1,250, my initial value, times 0.87 to the t. Now, if this was increasing, so this is because it's decreasing, we're going to use the minus, right? Okay. If it was increasing, I'd use the plus. Okay, so it'd be 1 plus 0.113. So like, for example, bank accounts that are getting bigger, that sort of thing, they end up increasing in value, so we end up adding. Okay, so addition is for increasing. And we're always starting at 1 because 1 is 100%. Okay, so in this case, it's 1 minus the 0.13. Okay, and if we're going to increase in value, then it would be 1 plus the 0.13. But that's not for our case this time around. Okay, so my model, V of t, I've got 1,250 times 0.87t. And what I'm going to do now is going to look in how many years will the computer be worth half its original value. Okay, now there's a couple ways to do this, but probably the easiest way with this one is because we're given an original value, half of it will be 0.5 times 1,250, which equals 625. That's half of its value. So what I'm going to do is I'm going to say, okay, well, 625 equals 1,250 times 0.87t. And one of the cool things about this is that this is basically like the equivalent of half-life. If we take 625 divided by 1250, which is the next thing that I'm going to do in my equation, I'm going to be left with 0.5 equals 0.87t. Now that I got 0.5 equals 0.87t, what I'm going to have to do now is I'm actually going to have to take the natural log of both sides. Okay, you can also take the logarithm. You can take the natural log of the log. So I'm going to take natural log of 0.5. Natural log of 0.5 is going to equal the natural log of 0.87t to the t. And so using our rules of logarithm, that's going to then give me the natural log of 0.5 is going to equal t times the natural log of 0.87. Okay. And then I'm just going to use my, so that, I'm then now going to divide by the natural log of 0.87. And so that means that t is going to equal the natural log of 0.5 over the natural log of 0.87. And I just utilize my handy dandy calculator. And that's 4.977. All right. Years. There we go. So just as a quick review, what did we do? Well, we noticed it's an exponential problem, okay? And by the way, I'm probably not going to give you that it'll be modeled by the function. You need to know how we actually go about modeling that function. But they're always of this form, a times b to the t, okay? So we have first an initial value, in this case 1,250, and then we have an amount that will either increase or decrease by, which in this case it decreases by 0.17, or 0.13, excuse me, and so hence that's why we use the minus. If it was increasing, then we'd use the 1 plus 0.13, okay? Now that we have that, we now have our model v of t equals 1,250 times 0.87t, and then we go through and we utilize our rules of logarithms in order to actually solve. Now remember, in order to take that exponential, right, and turn it into a variable that we can then solve for, we have to take the natural log of both sides, all right, and then use our rules of logarithms. That completes this video.